Next, let me learn the topic hydrolysis of salt of strong base and weak acid. In the last, we have seen strong base and strong acid. Now, the second one is strong base and weak acid. So, strong base example sodium hydroxide NaOH. Weak acid example acetic acid CH3COOH. Let me see the neutralization reaction between the weak acid and strong base. So when acetic acid reacts with sodium hydroxide, after the removal of water, the remaining is CH3COONA, which means sodium acetate. So this is a salt produced in this neutralization reaction. Like we have seen, here we have the positive and negative ion. So the positive ion is Na plus and the negative ion is CH3COO minus, acetate ion. So acetate ion is said to be a conjugate base of the acid, acetic acid. After we have removed H plus ion, the remaining negative ion is said to be conjugate base. And the Na plus ion is said to be conjugate acid of base. After we have removed the OH minus ion, the remaining positive ion is said to be the conjugate acid, right? So the conjugate base is acetate ion and the conjugate acid is Na plus ion. So here the base is NaOH and the conjugate acid is Na plus, right? We all know that NaOH is a strong base. If the base is strong, a concept, if the base is strong, then the conjugate acid will be weak. Right? If the base is strong, then the conjugate acid will be weak. If it is weak, then it does not react with water. So the conjugate acid Na plus does not react with water. Next we are going to see the acid. So the acid is acetic acid and the conjugate base of this acetic acid is acetate ion. As we know that the acetic acid is a weak acid. So if the acid is weak, then the conjugate base is strong. If the acid is weak, then the conjugate base is strong. So if it is strong, it can able to react with water. Which is able to react with water? Acetate ion is able to react with water. Let me see how the acetate ion reacts with water. So when acetate ion reacts with water, we know that water has H plus and OH minus ion, right? So the H plus ion of water has been taken by acetate ion, right? So CH3COO minus takes H plus and it becomes CH3COOH. What is remaining in water? OH minus is remaining. So OH minus is remaining in the resultant solution, right? So comparing the concentration of H plus and OH minus, H plus ion concentration is less because H plus ion is taken by acetate ion. So comparatively, OH minus ions are greater than H plus, right? So the concentration of OH minus ion is greater than the concentration of H plus. So in H2O, H plus ions are taken by acetate ion. So the resultant solution contains OH minus, right? So because of the OH minus ion excess in the resultant solution, so it is basic in nature. Now we will find the relation between the equilibrium constant for the hydrolysis reaction. Equilibrium constant for the hydrolysis reaction is denoted by the letter KH. And the dissociation constant of the acid hydrolysis, it is denoted by the letter Ka. So now we are going to find the relationship between KH and Ka. What is KH? Equilibrium constant for the hydrolysis reaction. Ka, dissociation constant of the acid. So first we will find out KH, which means equilibrium constant. So which is acid hydrolysis, as we have seen in the last. The reverse reaction, which means the acetate ion reacts with water. It gives acetic acid and OH minus ion. So this reverse reaction is said to be salt hydrolysis, right? So we had conjugate base and conjugate acid. So the conjugate acid is a weak, so it cannot able to react with water. But the conjugate base is a strong, so it can able to react with water. So it reacts with water and gives their acid back, right? So because of this backward reaction, we had OH minus ion excess in the resultant solution, right? So now for this reaction, we are going to find out the equilibrium constant KH, right? So what is KH? KH is equal to concentration of the product by concentration of the reactant, right? So what is concentration of the product? What are the products? Acetic acid and OH minus, right? So you write the concentration of acetic acid and concentration of OH minus ion by the reactants. What are the reactants? Acetate ion and water. So concentration of acetate ion into concentration of water. So this is equilibrium constant for the hydrolysis reaction, products by reactants. Let me alter this reaction. So KH has been written as CH3COOH and concentration of OH minus divided by concentration of acetate ion. So we have taken out concentration of water molecules. Why did we remove concentration of water from the formula of KH? Because the amount of water taken for this reaction is large excess, but the amount taken by the acetate ion is very less. Have you understood? We have taken large amount of water, but the water taken by acetate ion is very less. So the initial concentration of water is approximately equal to the concentration of water at equilibrium. So there will be no change in the concentration of water. So concentration of water is constant. So if it is constant, we no need to mention when we are writing KH and whatever the equilibrium constant. For example, initially we have taken 1000 ml of water, which means 1 liter, right? But at equilibrium we have 999.5 ml, which means the amount of water taken by acetate ion is 0.5 ml. So the concentration, initial concentration of water is 1000 ml and the concentration of water at equilibrium is 999.5. So it is approximately equal to 1000 ml, right? So the concentration of water at equilibrium is approximately equal to the concentration of water at initial. So that's what it has been taken as a constant. So the constant term cannot be denoted when we are writing the equilibrium constant. So concentration of water is removed. So what is KH? KH is equal to concentration of acetic acid, concentration of OH minus ion divided by concentration of acetate ion. Let me take this as equation number 1. So next we are going to find Ka, the dissociation constant. So the dissociation constant for acetic acid. Dissociation, we know very well that acetic acid is a weak acid. It dissociates into acetate ion and H plus ion. So for this Ka is equal to the same products by reactants. Products, what are the products? Acetate ion and H plus ion. So concentration of acetate ion and concentration of H plus ion. And what is the reactant? Reactant is acetic acid, has been written in the denominator. So this Ka equation should be taken as equation number 2. So when we multiply equation 1 and 2, what is 1? Kh. What is 2? Ka, right? So Kh into Ka is equal to CH3COOH, OH minus ion divided by acetate ion into CH3COO minus into H plus divided by CH3COOH. So here in denominator we have CH3COOH and in the numerator we have CH3COOH. Both will be cancelled. Like that acetate ion also will be cancelled. So what will be the remaining? OH minus ion and H plus ions. So we got the equation KH into Ka is equal to H plus ion concentration and OH minus ion concentration. So this we can write as Kw. What is Kw? Kw is a ionic product of water. So ionic product of water is denoted by the letter Kw, which is equal to H plus ion concentration into OH minus ion concentration. So finally we got the term Kh into Ka is equal to Kw, and this is the relationship between Kh and Ka.